Okay, people, you have a test on Monday. Did you get your packets back? Okay, so this must be from the others. So your test is on Monday. It will be like fill in the blank first. That's the only part I've done. Maybe multiple choice, and then problems after that. Okay. So with fill in the blank, you should understand things like the definition of momentum, conservation of momentum for elastic and inelastic collisions. In terms of a collision, why we would look at momentum changes and things in those instead of looking at directed things like the forces involved all the time, how momentum change relates to force and time, that's called impulse, with the impulse momentum theorem, how to work with that, and impulse momentum graphs, right? And then things in relation to work and how the work done ends up in an energy change, and types of energy, gravitational potential energy and kinetic energy, and then how to apply those with conservation of energy problems. So if you know all that, you should be good. Oh, and vector momentum, right? So let's go through some problems like that so you can get a little more comfortable with what I just said. And, huh? Yeah, well, I'm recording this so you could watch the review of the rest of it from that. If I remember to post it. Well, I don't think you need to go 20 minutes early, do you? I just got to find it. So let's take a problem where, like, let me give you, say you had a 2-kilogram ball. I'll just make it up since I can't seem to find the sheet I'm looking for. Say you had a 2-kilogram ball, okay? A 2-kilogram ball has a kinetic energy of 20 joules, okay? What is the ball's momentum? What do you think about solving that problem? Okay, so that's one thing we would need, right? And then K equals 1/2 mv squared as well. So P equals mv. And then K equals 1/2 mv squared. Now in this case, it didn't talk about a change in momentum or a change in kinetic energy. It just simply said you have at an instant, we want to know at this instant what is the ball's momentum. You were given kinetic energy. So now I have these equations. What would I do first? Solve for V with kinetic energy. Okay. So I know 20 joules is 1/2 mass of 2 kilograms times V squared, right? Multiply the 2 over. Oh, and then divide by 2. What's a joule over kilogram? A meter squared per second squared. And the square root of 20, 4.47 meters per second. So I found my velocity from kinetic energy equation. Now what do I do? So we'll take it in and put it up here, right? So P equals 2 kilograms times 4.47 meters per second. Okay, so I mean another way to look at this is like, okay, so you have those two equations, right? If you solve them both for V, so V is both P over M, and from this one up here, V squared is 2K over M, right? So 2K over M equals P squared over M squared, because if V squared is this and V is this, then I could, this is actually 6.1 momentum, but combining it with a little energy. So I'm just saying I can mess with the equations a bit, right? So if I give you something, I could ask you, is this true that M equals P squared over 2K? Well, if I brought it up, I could ask you on the test, is it true that M is P squared over 2K? Right? So from this equation, by the way, we wouldn't have even had to find the velocity, right? We could have just plugged it right in from there. Okay. What? I hope so. All right, number 2. 0.23 toy car, kilogram toy car, is moving east along the floor. Bless you. At 3 meters per second. When it is struck from behind, when it is struck from behind, by a 0.6 kilogram, 0.6, sorry, kilogram suction cup dart. We've all been shot by these, like at the mall, by some annoying kid, right? Traveling at 14 meters per second. Assuming an inelastic collision, I'll just write inelastic. What is the final velocity of the car? Okay, so now, what's my first step with problems like this? Draw a picture, right? So, toy car, right, is moving east. Like so. It's struck from behind by a suction cup dart. Moving like so. We want to know what the velocity of the combined wreckage is. So what do I do for that from this point? Conservation of momentum for an inelastic equation, right? So we got m1 v1 plus m2 v2, masses added together, v prime. Okay. So my m1 could be for the car, and the car is 0.23 kilograms. And it's going at 3 meters per second, plus the mass of the dart, which is 0.06 kilograms, and that's going at 14 meters per second. What would be the total mass? Because now they're stuck together after, right? 0.29 kilograms. And then we just solve for v prime. It's quite easy, right? 0.23 times 3 is 0.69 plus 0.06 times 14, 0.84 equals 0.29 v prime. So add these two together. Oops. .53 kilograms times meters per second equals 0.29 kilograms v prime. Divide 1.53 by 0.29, 5.3 meters per second. So the car increased its speed, didn't it? The dart slowed down, but for the car we could say everybody needs a shot in the hinder every once in a while, right? Thanks for those of you who at least tried to laugh. The rest of you, you solidified your minuses on your grades. Whatever grade it is. If you want to solidify your plus, not really, but if you want to help me tomorrow, I need help at the Young Artist Workshop. Make Nightlight 2.0. Okay? Yeah, that's the I use tape with it. Well, you just put tape on a jar and hang a light in it, basically. It holds in some metal. Sure, you can make your own. You get a free little LED light with it in a jar. It's here at Nichols. It will be with 4th graders and some 3rd graders. It's tomorrow morning. You'd have to be here about 8:30 till noon. You can get free lunch. I can't guarantee you that you get a plus on your grade for coming, but, you know, I would appreciate the help. You'd be in class all over the place. Huh? No, it's in the middle school. See me later today if you want to help out. I'm kidding about the plus thing. I can't really give you points for coming. Okay. But I could write a nice sentence on your comment about it. It was so nice Paul showed up to help me with my young artist. Although it was inappropriate for him to discipline that 4th grader, I appreciate his help. All right, let's say a car with bumpers, bouncy bumpers, going at 30 meters per second. We'll say the car is, we're going to put in a 1,000 kilogram car with bouncy bumpers going 30 meters per second. Hits a stationary car of 2,000 kilograms. Okay? We'll put east. Okay. The first car bounces off at an angle 30 degrees south of east. The second car, I'm making this up in my head, so I have to think a little bit of it. The second car bounces off at an angle of 60 degrees north of east. What is the velocity of both cars after the collision? What do you think? What's my first step? Draw a picture. I'm going to go with plan view on this one, like north, south, east, west, like that. Car. Well, it doesn't matter, I guess. Here's the first car moving along. Like so. And then that car hits the stationary car with the big heavy tires on it. That doesn't look like a car. Okay. That's stationary. And then once they hit, the first car bounces off at an angle 30 degrees south of east. Oh, come on. Please. So this one is going to go off like that at 30 degrees, right? And the red one's going to go off at, the second car bounces off at an angle 60 degrees north of east. North of east, so 60 degrees from here, like so. Okay? Now, what do we have to start with here in terms of working with this? We know it's a vector problem because it's off in 2 dimensions. Okay? But you have to, so you can't just use m1 v1 plus m1 2 v2 like that equals m1 v1 prime without the vectors in it. So you can't just do it straight as 1 dimension. You have to do it as 2 dimensions. So the way to do that is you start with the momentum of the first car plus the momentum of the second car equals the momentum of the first car after plus the momentum, plus the momentum of the second car after. Pay attention. How could you not look at a car going by? All right, so what is P1? Originally? It's all in this, and it's P1 will be 1,000 kilograms times 30 meters per second, or 30,000 kilograms times meters per second, right? What is P2 originally? 0, because it's not moving. So the first side of this equation becomes 30,000 kilograms times meters per second to the east. Looks like that. That's our initial P. We did, with the ball bouncing off the wall. And I did one in class. Remember when I did the one in class like this? So if that's 30,000 kilometers times meters per second, then we look at it and say, that has to equal, what does this have to equal after? It has to be what? 30,000. It has to be the same, right? So that's the key to the problem. Because it has to equal that after. So you have to get 30,000. You know this, that this P2 prime is off at 60 degrees, right? And then, wait, let me make that blue. I'll correspond it to that. And P1 1 prime went off at 30 degrees. However, these can move around because the two of them have to add together to give you what? 30,000. This is P1, isn't it? No, wait, what did the first car do? The first car went off at 30 degrees south. So this is P1 prime, and this was P2 prime. Now, if this is 60 degrees, what's this angle right here? 90, so this must be 90 as well. And this is 30, 60, 90 triangle, isn't it? And we know what the hypotenuse, yes. What is, so we know the hypotenuse is 30,000. And now we can find our pieces to the hypotenuse. Can't we? You see? Because we could find this leg and this leg. Is a 90-degree triangle? Well, the last one that we did in class, you were able to find the components of each one. Yes. Yes. So. All right, so let's find it. P2 prime. You see your right triangle here? This is the hypotenuse, right? So P2 would be to 60 degrees would be the adjacent. So 30,000 times the cosine of 60 degrees. $15,000. Well, you know, right? Because you've been doing these triangles in class, haven't you? So you know 30, 60, 90, that the short leg is a half, right? And the other leg, well, yeah, sure, if you want to, because it's 30, 60, 90, right? And then P1 prime would be, but you see, I don't never remember those, you know, times the sine of 60. $25,981, or square root of 3 over 2 times 30,000. It asked for their velocities, though, didn't it? Not their momentums. What do I have to do? Divide by their masses. So this one, that corresponds to the second car that had a mass of 2,000 kilograms. So V would be 15,000 over 2,000, or 7.5 meters per second at 60 degrees north of east, right? And then the other one would be 25,981 divided by 1,000, or 24 5.98 meters per second at 30 degrees south of east. Because that was the direction it's going in. So on the test, it's either going to be a problem like this, where you have a triangle that works out with the 90 degrees, or one like I did earlier with, I think I did a melon exploding, like an explosion one where they go off in 3 directions. So the initial is 0, and you have to get the vectors of you have to add 2 of them together to get the first one. Remember doing that? So you have to do the vectors of each, or one like the ball bouncing off a wall. So those are the 3 situations that you should look at. And if you know those, then you'll be ready for the vector problem on the test. Okay? Does that make sense? Does it seem unfair? Is class over already or something? But sometimes you got to be careful. Like, make sure you're not making it 2 dimensions if it's only 1 dimension. Like if one piece goes this way and another piece goes this way, and you started at 0 and you blew up, then it's all going to be in 1 dimension instead of 2. How about this problem? I don't even know what time class ends, so. No, 4, right? All right, a 400 kilogram elevator is lifted 30 meters in 12 seconds. Oops. What is the work done? And then what is the power? Sometimes if they say what is the power, you might say what is the wattage? Because power is measured in watts. So work is what? F delta S. And the force here would be what for an elevator going up? What are we working against? So it would be what? Which would be 4,000 newtons times delta S of 30 meters. $120,000 what? Joules, right? No, these aren't the joules. I'll put that. Power, which is capital P, right? Maybe you just want to write pow or something, so you don't confuse it with delta P, change in momentum impulse, or P, momentum. Little p is momentum. Work over time, we already found the work. And the time was 12 seconds. $10,000 watts. What is it measured in, Aiden? Watt? Watts. Okay, that's good. I think the bell's going to ring soon. I don't know.